Here goes Mr. Dean here. We're talking about reviewing for the Pre-Calc X final exam. Here goes nothing. We're going to try to get this whole thing done in about 20 minutes. So, number one, when the function is divided by x plus 3, the remainder is 0. So it's telling you that this goes in, right? So we do a little bit of synthetic division. We take off the 2, the 10, and the 12, put those into the problem. We're going to divide by negative 3. Don't be caught thinking you're going to divide by positive 3. It's the 0, right? The 0 is negative 3. And we end up with this 2x plus 4 with a remainder of 0. That 2x plus 4 can be further factored to 2 times x plus 2. So our roots are negative 3 and negative 2, right? Because the factors are that 2 times x plus 2 and the x plus 3 that they gave you in the beginning. So your roots are there. Number two, we're going to synthetically divide again. We're just going to set it up. We're going to be careful. There is no placeholders to worry about. And every one of my coefficients in the answer is going to have one fewer x exponent than it had in the beginning. So for example, the very first one was an x to the fourth. So our answer is going to have x to the thirds and so on. Plus 6x squared minus 2x plus 12. And then this remainder, we're going to write it with the negative 4 over x plus 2. That's how you write the remainder of that. And that remainder means that x plus 2, in this case, that x plus 2 does not divide in. It also means that negative 2 is not a 0 of this function. And bonus, it does not go through the graph at x equals negative 2. You don't have a 0 there. Number 4, you kind of split it up, and you want it to be an a plus bi form. And put that kind of together in front of the I, right? Some people were wondering if it should be 5I root 2. You kind of treat I in the sense of a variable where you put it at the end. So we'll have the real part, 3 halves, plus or minus 5 halves root 2I. Number 5, draw a qualitative graph. So the end behavior, I know, we're going to be leading off with a negative x cubed. Really, it's going to be negative 4x cubed if I worried about the numbers. So it's going to be x times 4x times negative x. So that tells me that the end behavior, it's a third degree, and the end behavior is going to look like that. And then I knew the zeros were negative 3 from that factor. Did a little bit of math here. It's 4x minus 1, so I found out that x is equal to positive 1/4. So there's a 0 there. Highlight those. And there's a 0 at 5, all right? Just be cautious of that one. So our graph looks like that with the end behavior. We're going to go through 3 times. So it's 3 real zeros, no imaginary zeros there. Number 6, if you get to use your calculator, well, you set it up, set your graph up. The real zeros are the ones you actually see where it crosses the x-axis. And we use calc menu, and we go to that 0 menu. And the calc shows positive and negative 1.91. So the other 2 zeros, there's 4 altogether, the other 2 must be imaginary zeros. Number 7, speaking of imaginary numbers, just be very careful and you distribute in a sense. Some say FOIL, F-O-I-L, and you want your answer to be a plus bi form. So I'm going with 18 plus I. Don't forget this negative 6i towards the end. I squared is equal to negative 1. So that negative 6i squared becomes positive 6, and that gets added to the 12. Next page. Doesn't ask us to graph this, but it gets us about as close to it. We need to factor, super important. 4x squared is 6x. We can take out a 2x. And when we do that, we see that we have created a hole. A hole is a removable discontinuity. There is a hole at, well, 2x plus 3 at the place where that equals 0. So there is a hole at negative 2/3. All right? Another type of discontinuity actually is a vertical asymptote. And it's not removable, though. The x plus minus 3 is there, and so there is a vertical asymptote. You can't pass it. X equals 3. Horizontal asymptote. Getting confusing here. We use different color. Horizontal asymptote is the ratio of the leading coefficients when their degrees are tied. Numerator and denominator are both sort of same degree, so we're going to say that we have horizontal asymptote at y equals 2. There's no slant asymptote. That would only be if the numerator's degree is greater than the denominator's degree. But in this case, it's not so nothing to worry about there. The x-intercepts are the zeros of the numerator. The y-intercept means just plug in 0. In this case, you got lucky. They're both the same. You get 2 for 1. They're both the origin. Number 9, let's reset this. I know people might want to go right into logs, but you don't need to. 9 is just 3 squared. And when you do that, you get that 3 squared raised to the x minus 2 is really just 3 to the 2x minus 4. We set this equal to that, and we get that. And so we get an answer of x equals 4. Number 10, evaluate exactly. That means no decimals, probably no calculator. So remember drawing these 3/4 pi is an angle out here, 45-degree angle, special triangles. Answer is √2/2. Tangent of pi over 6, remember pi over 6, that's 30 degrees, so you have a 30, 60, 90. And the tangent, so this was a little harder to do, so a lot of times we just said, just memorize that the tangent of 30 is √3/3. But you have the opposite, which is 1/2, divided by the adjacent, which is √3/2. You got your reason why, just invert and multiply, and then you got to kind of figure it out with the rationalizing the denominator. So we got √3/3 there. Cotangent of 2 pi over 3, well, tangent's opposite over adjacent, so cotangent's going to be adjacent over opposite. To do a bit of math here, you can see me working it out, but you do get negative √3/3. Don't forget about the negative there. Number 11, sketch a graph. All right, we got a bunch of things going on here. The amplitude is +3, even though that number is -3, amp's always positive. The b number is 1/2, and what that means is you take the period and you set it equal to 2 pi divided by the b. Well, 2 pi divided by 1/2 is 4 pi. The c number is the horizontal shift in either direction. It's usually like in with the x, and there is no plus or minus with the x in the original problem, so we're going to stay with 0 there for c. And d is your new middle. D is the vertical shift. All right, when I graph this, this is really a dashed line. That's where I start. I'm going to dash a horizontal line at 1. That's where we start. Then I go 3 above and 3 below because of my amplitude. So I'm going to dash another line at 4 and dash a line down here. 3 under 1, so that's -2. And I know it's a negative sine wave. I know the period of it is 4 pi. So I'm going to start here in the middle. And I know that halfway through my wave, I got to be at 2 pi. All the way through one entire wave is 4 pi. My period is 4 pi. And then I just continue that on with these special points. Now I also could be right in between there, between 2 pi and 4 pi is 3 pi. I have a maximum. And then at regular old 1 pi, I do have a minimum. And this just continues on. Don't be afraid of the negative side of things. This is way out at -4 pi. All right, number 12. Radians, well, they're an angle measure, and they're specifically taken when the radius of a circle is equal to the arc length. Number 13, the famous old box problems. I don't know if you can read what this says here. This is 66.15. All right. Box problems are where, let me rewrite it, where you have an 8.5 inch side, but you're taking out a little bit, right? Taking out an x on each side. So that side is 8.5 minus the 2x, because once you fold it up, you only really get, let me try another color, you only really get that length. If you go this way, don't forget you've cut out the same box corners on that direction, so what used to be 11 inches is now 11 inches minus 2x. So that's also x, this is x on this end. And when you fold the box all up, this is the bottom of your box here, that's the bottom. When you fold it up, the height of the box is x. Right? You got a three-dimensional box, so you got a third-degree polynomial equation here. You stick that into your calculator, and real quick, it's going to give you a graph that's sort of like that. And the part that makes sense in real life is this part here, and we're looking for that maximum, which is 66.15 inches in terms of the volume. All right, number 14, list all the transformations. This shouldn't be too bad. We're going to do it in order, though, right? It does follow order of operations. We want to go right first, and then that stretch of 3 times the vertical stretch. Next page, number 15. Can't do a log where the argument's negative, right? Change a base formula, sure, we can change it to log negative 27 over log of 4, but there's still no answer there for number 15a. 15b, you can do it. Log of 49 over log of 2. We've changed the base to 10 so that we can go into our calculator. So you literally just press on your calculator log of 49. Just don't forget about you're doing a log divided by a log and not just log of 49 divided by 2. That's not the same. 5.61 for that one, and finally 4.29 for the very final one. No tricks on that one. Number 16a. To find the zeros, we often have to factor. So you need to factor out both a 2 and an x. And students are a little weary of that when you have to factor out a variable also. What's left behind is something that's very factorable. I don't know if you can see what I wrote. X plus 4 and x minus 3. And so our zeros are that produced a 0, that produced a negative 4, and that x minus 3 produced a positive 3. So you got those 3 zeros right there. 16b is kind of interesting. It was tough to factor, but I realized that with this being a fourth power, this being a squared power, and this just being a plain 14, we can factor it into x squared minus 7 and x squared plus 2. If you work it out, it'll work. Negative 7 plus 2 gets you the negative 14 at the end, for instance. If I further factor each of these, right, x squared minus 7, it can be positive or negative root 7. It doesn't tell me in the directions whether I need to just worry about real numbers or if I have to worry about imaginaries. So I went all the way and I factored. Of course, I didn't really factor. I solved. X squared equals negative 2. So square root of both sides means that. So I kind of overdid it. I don't know if they were talking about just the real numbers. I have 4 answers, though, and it's a 4th degree polynomial. I found all 4 roots, whether they're real or imaginary. Number 17, the 3 methods to determine if it's a factor. Well, it is a factor. How do I know that? Because when I sub in negative 3, I get 0 at the end. That means it's a factor. If I type that all into my calculator graph, type that into y1 in my calculator, I would find that one of the zeros was negative 3, where it crossed through the axis. And last but certainly not least, just going to be careful of my placeholder. I use synthetic division, and my remainder is 0. So when I get a remainder of 0. So all those things point to the idea that x plus 3 is a factor. Number 18, for that complicated function, we're going to set our calculator up. So let's see what we can do here. Maybe we'll try this. See what I got. I got it in there. Try to graph it. Now I use this, I have the window kind of all set for this. You have to mess around with your window so you get everything in there. I know it was a 3rd degree polynomial, so I knew that just going a regular window, I always thought was a parabola. So I got to expand out and see the whole thing. I want to see the maximum there. I want to see the minimum there. All right. And I just go to my calc menu to find my minimums and my maximums, and I follow the left bound and right bound information. It turns out that these are our minimums and maximums, and we report those as an xy coordinate, whereas the intervals, we only worry about the x-axis, the x values. And this is like an xy point. Not a crucial big deal, but it makes sense. Increasing twice, so it's increasing at the beginning, then it goes down for a while, decreases, and then it increases again to infinity. Number 19, completing the square. Love it. All right. 4 does not complete this, or does complete the square. What I did was I took the b number, took half of it and squared it. And that got me that positive 4. And that's perfect. I moved a minus 4 to balance that out, and I moved that plus 7 on the very end. So on the end here, your kind of outcast numbers are positive 3. The ones that make the perfect square is x minus 2 squared, and so your vertex is 2, comes from that, positive 3. All right, last page. Now, I got to apologize. This says find the exact values of each right triangle. The only one you can do exactly is this one. You're going to need a calculator for the one on the left. Turns out that you could use many different trig functions here. We'll just use tangent. Tangent of 71 is equal to opposite over adjacent. That's how I got a over 5. All right. Once I knew A was 14.5, I used the sine of 71, which is the opposite over the hypotenuse. And I got 14.5 for A and 15.4 for C. Now a different story over here. I don't need a calculator. So what's given to me is just the 30 degrees and the 5. Remember, don't use law of sines here. You don't need law of sines. It's too much. Just use the SOHCAHTOA, right? This is crucial for right triangles. Doesn't work for non-right triangles, but when you do have a right triangle, you definitely can get away with a lot by using it. And see, I can just say sine of 30 degrees is equal to, from the point of view of 30 degrees, opposite over hypotenuse. It's opposite. I didn't know what that opposite was, but I do know the sine of 30, or I should, is a half. So it turns out that opposite side is 5 halves, or 2 1/2. And I do the same thing with the other side to try to get that. I could say cosine of 30 is equal to, cosine of 30 is equal to, I didn't know this, the adjacent side over 5. Cosine of 30, rewrite that. Cosine of 30 is root 3 over 2. So cross multiply and divide to get what A is, and you get 5 root 3 over 2 is the adjacent side up there. All right. 42-foot ladder leans against the building, so you got a 15-foot span there and a 42-foot ladder and a right triangle. And you can easily find this side by Pythagorean theorem, but you do not want to waste your time doing that. It doesn't ask about how high you go off the house. It asks what the angle does it make. You need trig, cosine theta. I chose cosine because it's adjacent over hypotenuse. And then I wanted to find the angle, so when you want to find the angle, use inverse cos, or inverse trig, whatever it is. And let's see here. Go inverse cos, 15 over 42. If I'm in degree mode, it'll spit out a degree, 69.1 degrees. Number 22, quadratic formula. Now be careful here. First, I got to set everything equal to 0. So that was an important clue. So I bring the negative 11 over, and I have A, B, C, right? So I got x is equal to the opposite of b plus or minus negative 11 squared. A lot of people will have negative 121. It's never negative there. B squared is always positive. So I got positive 121. The other mistake is just being sloppy with the negatives in here. So be cautious. Do that all, whether you do it in a calculator or you do some of it out by hand. Either way, they should match up, and you get negative 1/3 and 4. All right, number 23 is a lot of SOHCAHTOA. It's great. All right. So given that tangent of x equals 4/5, find the other 5 trig functions. One thing I should add is that it has to be in quadrant 1, not in quadrant 3 to start off with. You didn't know that. So 4/5, right? This is the angle here. Tangent is opposite over adjacent, so that's where we get that from. All right, and you can read through here. I rationalize the denominator each time. And so here are our 5 other answers. Cotangent was an easy one. It was the reciprocal of tan, which is 4/5, so we got cotangent 5/4. All right, number 24 has to do with the difference formula back in trig. This is for cosine. I split 15, or I made 15 the split of 45 minus 30. Remember there's a cosine difference formula. When we're finding the difference, we actually add cos and sine. All right, and then you just have to remember it's great if you remember your values really well. Cosine of 45, cosine of 30, that's a root 3 over 2 right there. Can't see that very well. Sine of 45 is also root 2 times 1/2. And you just have to remember how to multiply fractions, and it's not until the end that you add them and care about common denominators. Final answer is a little rough here. Root 6 plus root 2 over 4. All right, last one. This was testing you on law of cosines. What you're given here in the diagram, I just wrote the diagram here, and what you're given is a side, an angle, and a side. Side angle side calls for the law of cosines. So I very carefully figured it out. You have to start with a squared because you know angle A. So a squared is all this. In other words, A is the square root of all this. And I wouldn't be shy to just type this all into your calculator all at once. Square root of 15 squared plus so on, so on, so on. When people break it up is when people have problems with the order of operations. So I let the calculator handle this whole thing all together. And it turns out that is 23, I'll rewrite it, 23.377. Oh, even when I wrote it out, it was weird. 23.377. And then when you go to the, very important, when you go to the, this is not important in this problem, you get a wrong answer if you don't do this. You got to go to the smallest angle next. Use the law of cosines to start. You don't have a choice of that law, you don't have a choice of where to start. You got to start with little a. But after you know that little a is 23.77, you have a choice of either B or C. In terms of now you're going to the law of sines. What does that say? Law of sines. And when you use the law of sines, find the smallest angle next. And that smallest angle is angle B. So that's why we went right after angle B next, because law of sines is not going to tell you that the angle C is larger than 90 degrees. It's not going to. It's going to tell you it's in this case it would lie to you and tell you it's 89.34, I think. Right? So find B, and then how do you find C? Well, if you know two angles, you just do 180 minus. So 180 degrees minus B minus the 50 degrees that's given gets you 100.56. So law of cosines first, law of sines next. All right, gang, that is it for the review. We will see you in class.